So let's start our presentation. So today, we'll just do practicals of what we learned last week on pandas, and moreover, I want to tell you about two things that we didn't cover last week. That is about creating data frame. So this is a typical structure to create data frame. So here you can see if we initialize the pandas, if we have an so here if we have an object such as if we have an pandas object such as PD, so when we do import pandas as PD, and we can create data frame using pd.data frame. And here we have to give the details in JSON format. I will tell you what is JSON format. So this data frame, as you know that we learned. So as you learn last week, data frames are nothing but data structures that are able to handle two-dimensional data. Mostly they are used for handling tabular data structures, like the table format, like the data in the table formats. As we can see an example of Excel sheet or Excel sheet where we have certain number of records with certain number of rows, that certain number of rows and certain number of columns, which typically gives us uh, data values. So the same thing can be depicted using a data frame. So when we load data from our Excel sheet, it is loaded through the data frame, and we can also persist our data to CSV file or Excel sheet file using this data frame. So like for example, here you can see data frame. How can we create data frame? So here you see pd dot data frame. This is the data frame object. And then here what we are doing is we are just starting a middle column. Then here we have the column name. The first, this value indicates the column name, and on this column what we would like to store is we would like to store multiple values. So here you see the list of values. So this double bracket means to say list of values. Like here we are storing three values. With name column we are storing three values. Similarly, then we have the age column, and we have three values here also. And with sex column we have also three values. So this is a two-dimensional data structure. When we would like to save this data file into CSV file, into Excel sheet file, save you can easily save this data structure into CSV file. So like when you just output this data frame, when you just say df, it will give the structure like this. And whenever you would like to save the data like this, so df dot to csv, you can do like this. Now similarly, there is for handling of single dimensional data, like that was the two-dimensional data where we have rows and columns. To handle single dimensional data, we have a concept of series in Panda. There is something known as series class in Panda. So when we say pd.series, here you can give the single dimensional data. So single dimensional data means directly an array. So when you say pd.series of something list, and this column name is something like age, now it gives you the record on single dimension. So series, there can be different operations we can implement through series or data frames. For example, of age, we have the age, like we have the series data age. And when you say of ages, data frame of ages dot max, it gives us the maximum value, right? So ages dot max. So here we are providing the values of ages dot max. So these are the functions we can directly execute. Let's see how this is happening. We can just check this using Google Colab or your notebook. So if I open Google Colab, in Google Colab, Pandas is already installed, so you don't need to install Pandas. But in your local system, what you have to do is you have to install Pandas. Okay. So here, initially what we have to do is we have, as Pandas is already installed in this Google Colab. If in Google Colab Pandas is not installed, you just have to install it using this not exclamation mark, then using pip command, pip install Pandas. You have to do like this. By default, it is already installed, so we don't need to install it. But in your local system, what you have to do is you just have to use conda prompt or something like that. Conda install, then pnds pandas. You do something like that, and it will install. Or you can also use pip. Pip command also you can use. Simply you search like conda install panda command. It will give you the command for how to install Panda in Conda. It will give you the Conda environment command. Conda install Python. If you want to install a specific version, then you just have to give pandas equal to 0 point something, something like that. So initially now for using the pandas, what we would like to do is we would like to import pandas in our system or file, import pandas as PD. So I'm just creating the pandas object and executed this. So this has just executed. If it is installed, if pandas library is found, it will successfully get executed. Now what I would like to do, so we would like to create one data frame. Let's say we would like to create data frame, df, data frame as df. So any name you can give of this. So we would like to create a data frame pd dot data frame. So you say pd dot data frame. And so what data structure we would like to create? We would like to create data set such as this. Okay, like here we have name column, age column, and let's say we have some salary column. We have 3 columns, and in name we have Prem, then Ram, then Sita. And here in age, Prem has age of 44, 32, and 31, something like that. And salary is 20,000, 40,000, 20,000, 40,000, and 50,000. So this is something like that. So if you would like to create this type of data structure and you would like to save this kind of value, so how can you do that? So you just have to tell us pd dot data frame like this here. So what you have to do is pd dot data frame. Inside data frame, you have to create the data structures like this. So how do you create data structure? When you say pd dot data frame, now you have to create data structure inside this bracket. So this is known as JSON format. As you can know, you also have studied about this format, this data format. As we learned about Python dictionary, so you might be familiar with this. So this is same Python dictionary structure. So this is same Python dictionary structure. So here what we are going to do is, let's say we are creating a column. E is represented as column. Let's say column is name. And then values we would like to give into this list value we would like to provide as a list. So here inside list, what we have to do is we want to create these values like Prem, Ram, Sita, right? So we have to, what we have to do is we have to, if it is a string, then we have to provide it into double quotes, comma, then here is Ram, and then here is something like Naresh. Okay, so this we created a column with value name, and a column with name, with name label, with label as a name, and value as three values inside column, and we do comma. Then we would like to create next column. What we would like to create, we would like to create age column, stating age of three people, so like 34, 24, and third one is like 20. Okay, comma. Now we would like to create third column, there was salary. Okay, so salary, we would like to state three salaries, 20,000, 30,000, 30,000, and let's say 40,000. Okay, this was the data structure. So if data structure is correct and you didn't do any mistake, so it will execute successfully. So when you execute this, it is executed successfully. Now you can check what this data frame contains. If you simply say df and do like this, so it will give you all those values like here, name, salary, and age. It has stored. Now it has already provided index of 0, 1, and 2, and it is something like that. So df, when you say df dot head, now all the operations whatever you would like to execute, you can execute. Df dot head will execute top 10 rows inside the data frame. As we have only 3 rows, so this is only displaying 3 rows. But consider that name might have 1,000, name might have 10,000 data sets, age also same, and so on. So this is the data frame. And similarly, for representing a single dimensional data structure, so if we have data set like single dimensional data, like we don't have this 2D data, we have just single column or single column value, or single only one set of group of values, then what we can do, so at that time what we can do is we can create new data frame with series, like for example series, that is single dimensional data structure is known as series. Like what we can say, df dot series, df dot series, series. Now inside that, what we would like to do, we would like to create a column, like for example if it is a label, for example let's say we are storing the values of salary only, salary, and here what we can give is salary, what we can give here is 2,000, 4,000. So something like that. Okay, and based on this thing you can execute that. So you have to provide directly the values first, and then you have to provide a tag. What is the tag for this? So when you execute this, see, this is not capital letter. But pandas dot, we are creating object from pandas. So it is PD. Okay, this was capital only. So here you can just see this one. Like this is the series object. Now you can do varieties of operations with this series. For example, s1 dot, when you say s1 dot, you can see varieties of operations associated with it. Like for example, align, argmax, as type, attribute. Like there might be operations such as min, max. For example, this is that. Now we would like to simply say s1 dot max. So what is the maximum value out of this s1 series data? So when you say this, so it provided us the value similarly, simply like this. So we don't have to do any computation all over. Similarly, you can also execute the same thing, like like we did here. Here now, for example, I would like to extract the salary information, df of salary. So here we have, I would like to say df of salary. Okay. Now I have a column df of salary. Now what it gives me, it gives me all the values as a series. When we extract element of single column, so this is treated as a series. So when you say type of df, now when I check type of df, so this is type of series. So once, if it is two-dimensional structure, it is data frame, and when we are extracting a single column, so this is treated as a series object. So when you say type of df of salary, so this is regarded as a series object. Okay. So this is series, and when you would like to execute, like for example, in series objects, you would like to execute a min value, min function. So you can simply execute like this. Now you have a data frame, and if you would like to, let's say you would like to save this, you would like to save this to the CSV file. So how can you save this? You can say like df dot to, simply there is one function. It's very easy. In df dot to underscore CSV. Here is df dot to underscore CSV. We have a function. Like here, we have to just give the path. Okay. Df dot to CSV. We just have to give the path. Path. Now let's say, for example, this is an employee file. So if I say mpl empl.csv, now when I execute employee, let's say, so what it will do is it will directly save this value into employee.csv file. It will create employee.csv file and it will save it into this employee.csv file. Now you can see here employee.csv file is already created, and when you open this file, so here you can see it has it it has directly saved its values. Like if you download this file, you download this file. So it provided us with this name, age, and salary. So this is by default populated. So this is the indexing. So when you do not like, when you when you like to avoid this, when you don't like to index, when you don't like to add these values, index values, what you have to do is you just have to put an option such as index equal to false, or there's something like that option. Maybe here, comma, here is index. If we say, for example, false, like what it says, let's say, what it does. So it has removed the index, right? So if you download this again, so if you download this again and you see here, so here you don't see this index 012, right? So this is the same, and last time we studied about how to read CSV files. So reading CSV file is also the similar one. So this is as simple as that. So I think, so let's practice today. Let's practice last time what we have executed. Let's practice that, and I shall stop this presentation. No, maybe I'll pause this recording and stop recording.